So, okay, myself, Dr. Navneet Kumar, and I am assistant professor there in PG Department of Mathematics, Purnia University, Purnia. And students, I am going to discuss you the convergence and divergence of geometric series. Now, firstly, you have to understand very clear about geometric series. So, what is geometric series? So, let take a geometric series as a plus ar plus ar square plus ar cube plus so on and plus ar to the power n plus to infinity terms. So it is what? It is an geometric series we have taken. I want to check how can I say that it is a convergent and discuss its convergence and its divergence. So first it is a geometric series and I know it is a infinite series. So what's the let a un is an infinite series and equals to infinity, and we can write it as un plus u2 u3 u4 plus un and plus so on. It is an infinite series and let sn is what? Sn is the sum of n partial terms of infinite series un. So what is Sn? Sn is the sum of partial sums of the series. So what's the value of Sn? Sn is nothing but Sn is u1 plus u2 plus u3 plus so on plus up to un. It is the partial sum. Partial sum means what is the S1? S1 is nothing but u1. What is the S2? S2 is nothing but u1 plus u2. What is S3? S3 nothing but u1 plus u2 plus u3. So such type, this is what it is, Sn. Okay. Plus. So what is the formula of infinite series to be convergence and to be divergence with help of this Sn? The formula is if limit. Oh, ये कहाँ चला गया था? इसको स्टॉप करिएगा. हाँ. Okay. Then what is the formula? Formula for convergence and divergence. The formula is when we take limit n tends to infinity Sn, and if its value is let s, where s is what? Finite. And if its limits value is finite, then then the infinite series is convergent. Then the infinite series is convergent. And what's about divergent? If limit n tends to infinity, Sn equals to plus infinity or minus infinity, then the series is divergent. And also if limit n tends to infinity is what? Does not exist. If this limit does not exist, it means it is what? Neither convergent, neither divergent. it means it is oscillatory. It is oscillatory. So this is the basic function of convergence or divergence of an infinite series. So this is an infinite series, summation un. This is a n partial sum of n terms, Sn equals to this. Then it is the formula. By using this concept, we can find the convergency, divergency of an infinite series. Now we take the next slide, page 2. Here in page 2, again we take a geometric series. Geometric series is this: a plus ar square plus so on ar to the power n plus up to infinity terms. Now what I want to check its convergency or divergency. So as I discussed here, the concept behind is this: the Sn is what? The sum of first partial sums. So what is the formula of n terms sum of n geometric series? It is Sn. What is the formula? A into 1 minus r to the power n upon 1 minus r, where r is common ratio and value where r is common ratio. So we can break this formula such like, we can write it as a upon 1 minus r minus a into r to the power n upon 1 minus r. What's the value of r? So r may be less than 1, r may be equals to 1, r may be greater than equal to 1, or we can say r may be less than minus 1, r may be equals to minus 1, r can be greater than minus 1. So there are lots of cases on which this geometric series depends its convergency as well as its divergency. Now how can I check? Then we have take on different terms. So first term I want to take when mod r is less than 1. So mod r less than 1 means what's the value of r? Minus 1 less than equals to r and less than equals to 1. So first it is our case 1. It is my case first. When mod r is greater less than 1. Okay. We know if value of r is less than 1, it means when limit n tends to infinity, r to the power n tends to 0. Because r is less than 1, then this limit tends to 0. That's why, what is Sn? Sn is, this is the formula of Sn. I am going to use this formula. So Sn is what? A upon 1 minus r minus a into, but as I take limit n tends to infinity, then this value becomes 0 because r to the power n is present here. That's why this value is going to a upon 1 minus r. R is less than 1. That's why 1 minus r is again a finite value. Hence, this is what? This is someone, but it is a finite value. So, as I discussed earlier, if limit n tends to infinity, Sn is finite, then the series is convergent. Hence, in this case, the geometric series, the geometric progression is convergent. So it means if we have a geometric series for which common ratio value of r is less than 1, the series will be what? Convergent if r is less than 1. This is our case first. Now I am going to take the second one value. It is my case 2. Okay. So this is my case second. Case second is what? When r equals to 1. So when r equals to 1. Again, the geometric series. What was my geometric series? Geometric series is a plus AR plus AR square plus so on plus AR to the power n plus so on. But value of R is 1. That's why the series is, and the sum of first n terms. So what is the, for which, what is the value of Sn? And when R is 1, then this Sn is what? And which terms? N terms. So what is the value is Na? Then what is the value of Sn? Sn value is Na. Take formula limit n tends to infinity Sn, then obviously this value is infinity, and because this value is infinity, therefore the series, yeah, the geometric series, the geometric progression is divergent. So what we get? So we get here, when R is less than 1, the series is convergent, but when R is equals to 1, the series is I prove here, divergent. I prove here this type. I prove here the GP is divergent. So I discussed two cases. Now going to another cases, I will take the next slide. Current next. Oh, add कर देते हैं. It is my page number 3. So I am discussing here two cases when R is less than 1, when R equals to 1. Another case when R is greater than 1. Take R greater than 1. So here again, when R equals to 1, the Sn value is A equals to NR, but R equals to 1, so Na. Obviously, when R is greater than 1, the value of Sn is obviously greater than Na, but when we take again limit n tends to infinity, then Sn goes to infinity, because Sn is depending on Na. So the series is again divergent in this case. Series is divergent. So series is convergent only when R is less than 1. Series is divergent when R equals to 1. Series is divergent when R is greater than 1. Now case 4, it is my case 3. Again I will going to case 4. So if R equals to minus 1, obviously when R equals to minus 1, take again what by my geometric series, A plus AR plus AR square plus AR cube plus A R to the power 4 plus so on A R to the power n minus 1, and its sum is what? Sn. R equals to minus 1, then this value is A minus A plus A minus A plus A up to minus A, and this value is 0, because we cancel out these all A, cup 0 if n is even. Even minus 1 if n is odd, odd. Or all A cancel and the last one, this A remaining if n is even. This value has two value Sn. It may be 0, may be A. Accordingly, if n is even or n is odd, it means we have a value 0 and A, but not a fixed value. Again, what is the case 5? When R is less than minus 1. When R is less than minus 1. Then again, what will be the value of Sn? Sn goes to again infinity, or maybe Sn goes to minus infinity. Again, if depending upon value of n is even or n is odd. It means the series is what? The series is oscillatory. It means series को watch which series GP है ना, GP is oscillatory because we have no fixed value when r equals to -1 or r is less than -1. So this is the terminology of geometric series. Now I will check through an example. So consider a geometric series, say one, any example, 1 by 3 plus 1 upon 3 square plus 1 upon 3 cube plus test plus 1 upon 3 to the power n plus so on up to infinity. And I want to check about the convergence or divergence of this series. This is a geometric progression. Clearly, here common ratio of r is what? R is nothing but 1 by 3. Obviously, the value of r is less than 1. So what is the Sn? The sum of first n terms. This is the sum of first n terms. Take formula. What is the formula of sum of n terms? A into 1 minus r to the power n upon 1 minus r. This is the formula. Here A is what? A is 1. A is 1. So what's the formula? 1 into 1 minus 1 upon 3. So how much the values are? These are value n. It means 3 to the power n minus 1 upon 1 minus 1 by 3. Obviously, this value going to 0 when we take limit n tends to infinity. So this value is what? 1 minus 0 upon 1 minus 1 by 3. It is 2 by 3, and this value is 3 by 2, which is what? Which is finite. Which is what? Which is finite. It means we have limit n tends to infinity, Sn value is finite, and because it is finite value, that's why this geometric series is convergent. This series is convergent. Hence, this series is convergent. Okay. Thank you.